Good day and welcome to the second in our series of the Spring Microfluidics webinar program. Today we're here to talk to you about the detection and characterization of viral pathogens, focused on how microfluidics can be used for this application. This is actually the second of our 4-week program where we started off last week by enabling mega insights with microfluidics. Today we move on to the detection and characterization of viral pathogens with microfluidics. In today's session, we're going to cover off on an introduction of why this application is important. That's particularly timely given the situation that we face with COVID-19. We're then going to talk about how the microfluidic technology can be used for viral detection. That will then lead us into our protocol dedicated to viral RNA detection. And then we'll round off today's session by discussing some of the publications that feature microfluidics from Fluidigm for viral detection applications. So let's start with the introduction. And with the introduction, we start with really exploring what the technical requirements in today's climate are for viral detection using microfluidics. Essentially, the technical requirements in the community really start with a scalable sample throughput. As you can imagine, this really relates to being able to screen enough individuals at a time. Because there's so many samples and because there's so much of the population impacted by things like COVID-19, there's a clear need to support high volumes of samples for applications in viral detection and biomarker research. There's also a need to perform rapid turnaround time to result. Of course, much of the testing that goes on has to lead to an actionable result. And so it's important that we have a rapid turnaround time to provide the results that drive care and treatment decisions. It's also important that we're looking at not just COVID-19, but other assays so that we can screen other respiratory markers at the same time. And so there's a technical requirement in the community to use assay capacity and coverage, enabling multiplexed assays within targets of interest, whether a specific virus such as the SARS-CoV-2 or a larger pathogen, a larger panel of upper respiratory pathogens. And all of this is also required to occur with high cost efficiency, meaning that we deliver high quality data and services that are within a limited budget to both the personnel and the lab that we serve. So in the community, as it stands today for COVID-19, there has to be scalable sample throughput, rapid turnaround time, assay capacity and coverage, and cost efficiency. What we're going to introduce to you today is an application that meets all of those objectives. Fluidigm Microfluidics enables you to meet all of the objectives of the technical requirements that exist in the pathogen and viral screening market today. So let's talk a little bit more about that. So what we've been able to build and what we're going to talk to you all about today is a solution that is versatile and scalable using microfluidics. In last week's session, you learned about the diversity of our microfluidic solution. Today, you're going to learn how that microfluidic solution can be used to scale the screening for COVID-19. You're also going to learn how our microfluidic platform enables flexible panel design. What we mean by that is that, of course, today, COVID-19 markers and the analysis of those COVID-19 markers at scale is very important. But as we move into the fall, and as we move into creating a more comprehensive view of what is going on with viral detection, being able to easily add or remove biomarkers within one panel set is very important. And our microfluidic platforms enable that. If you recall from last week's webinar, we mentioned that you can add assays and remove them on the fly. This objective is key to being able to scale any technology and being able to get a more comprehensive view of what is happening at the pathogen level per sample. The Fluidigm response also showcases simplified workflows and automated platforms. What we mean by that is that we're able to improve productivity and drive a return on investment, because our workflows are pretty low hands-on time, but maximal data output. And the whole foundation of microfluidics, as it stands, relates to using very small reaction volumes. And in using these very small reaction volumes, we're able to offer superior cost savings, maximizing the lab budget by minimizing the reagent consumption using microfluidics. So in last week's presentation, we really covered on how all the microfluidics with the systems, with the IFCs, the integrated fluidic circuits, with the reagents, and with the design assays all came together. And we showcased that across all of our different microfluidics offerings. Today, we want to refine that right down to just focusing on pathogen detection and viral detection. So in doing so, let's take a look at our 4-blocker again. Our 4-blocker from the last presentation was really that Fluidigm genomic analysis systems deliver solutions for automation and microfluidics. This, for pathogen detection, really focuses on 2 instruments. The first, shown on the left-hand side of the slide, is the Juno system. And that Juno system is used to prepare integrated fluidic circuits, meaning that, as a user, you pipette the samples and targets onto the microfluidic device, and then the Juno platform does all of the rest of it. It is able to take the samples and assays and put them into the chambers within the chip to allow the PCR reactions to happen. Once that's complete, it then goes on to the Biomark HD platform. The Biomark HD platform is the platform that performs the real-time PCR application that we're going to talk about today. Both the Juno and the Biomark HD platform utilize our 192.24 integrated fluidic circuit shown at the right-hand side of the slide. That means per integrated fluidic circuit, you can analyze 192 samples across all 24 assays. And as a reminder, from last week's session, we were able to showcase that each sample sees all of the assays in parallel. And that's very important in the case of pathogen detection and viral screening, because it means that that one sample does not have to be split across different reaction vessels. And it means that that one sample of precious material can be assayed across COVID-19 as well as other respiratory markers or other markers of interest at the same time. Further to this, we also have the reagents and the assay design shown at the bottom of the slide. Those reagents are reagents that enable you to use reverse transcription, preamplification, plus all of the buffers that are used to process the integrated fluidic circuit. And as we've mentioned a couple of times in this presentation, being able to use additional markers on the integrated fluidic circuit is key to the flexibility of our microfluidic approach. And the D3 assay design service enables you to put your markers of interest in and get assays out. So what it means is that for viral detection, Fluidigm genomic analysis systems enable you to drive automation and microfluidics with a complete workflow. So that's the overall introduction, and that really showcases much of what we discussed in last week's overall introduction session. Let's move into a little bit more detail of how the microfluidics are used for viral detection. One of the things I mentioned on the previous slide was the use of the 192.24 IFC. Let's talk a little bit more about that integrated fluidic circuit now. On the right-hand side of the slide, you can see how our integrated fluidic circuit actually looks. You can see again that it's the same size as a 96-well plate, and that interaction with this 96-well plate is the same as if you were using a multi-channel pipette or liquid handling robots. Per IFC, we have 192 sample inlets. These are shown on the left and the right-hand side of the square in the middle of the IFC. Further to this, we have 24 assay inlets. These are shown at the left and the right-hand side of the IFC. And so per IFC, we are able to look at 192 samples across all 24 assays in parallel. And that's what this microfluidic reaction chamber image is showing you. Every sample will see all 24 assays. This means that there's no need to split your sample up into individual reaction chambers. There's no need to worry about preserving your sample, because with the Fluidigm workflow, you're able to take each sample, of which on this IFC there's 192, and look at all 24 markers at the same time. In reality, what this means is that you can achieve, using our microfluidics, greater cost effectiveness. We deal in nanoliter reaction volumes versus microliter reaction volumes on 96 or 384 well plates. That means because you're using so much less volume that the workflow is much more cost effective than other plate-based workflows. It's also more cost effective because the hands-on time of using a microfluidic device is way lower than using a 96 or a 384 well plate. That also enables you to load and go, meaning that you pipette the samples and assays into one integrated fluidic circuit, and then the Juno and the Biomark HD system take care of the rest, load and go. We also enable you to scale sample throughput. What that means is that in this example, we are showing you one of our 192.24 IFCs, but in actual fact, as you learned in the previous session, we've got integrated fluidic circuits that can do all different levels of throughput. So we offer a technology, a foundation technology that can be scaled without having to change methodologies. And lastly, we can add, remove, replace assays on demand. These integrated fluidic circuits arrive in your lab empty. They're not pre-spotted with assays. We do not lock you into a panel, and we do not lock you into a chemistry. You can put what you want on those chips. So this whole process of the 192.24 IFC enables the automation of molecular biology in nanoliter volumes. The key take home on this slide is that in this IFC and the workflow that it allows, you can actually process 33 of these IFCs in one 24-hour period. What that means is that if you've got RNA that's already extracted from patients or from samples, that you can process 6,336 tests per day. 6,336 tests per 24-hour period. That's the equivalent of 48 96 well plates. This is really the scale and the beauty of this microfluidic device. The ability to screen many thousands of samples in a 24-hour period. These microfluidic devices give you the scale that is not possible or easily achievable on a 96 or a 384 well plate. So let's take a look at the systems that really are attached to these microfluidic devices again. We spoke again in the last session about a whole range of genomic systems that we have available. In today's session, we're going to really focus on two systems. We're going to focus on the Juno system, and we're going to focus on the Biomark HD system. As we mentioned last week, and to refine it this week, the Juno system, shown at the top of the slide, is the preparatory device. This preparatory device processes all of our integrated fluidic circuits. So when we talk about the 192.24 IFC, that 192.24 IFC can be primed, and the samples and assays can be loaded using the Juno system. And that prepares those samples and assays to then be ran on the Biomark HD platform. The Biomark HD platform is the analytical platform that performs the microfluidic real-time PCR detection. It's that system that enables you to understand the level of expression of your viral markers, and whether they're present or absent, and how they compare to the control samples. So, in this example of pathogen and viral detection, the Fluidigm systems for genomic applications that you should take attention to are the Juno system and the Biomark HD system. As an aside, and as you will learn in coming weeks, the Juno system also sits up front of any Illumina next-generation sequencing platform. And so again, in the next couple of weeks, you're going to learn how the Juno platform can be used to prepare libraries for next-generation sequencing. But for today's session, just take note that the Juno, the Biomark HD, and our microfluidic devices are the workflow components required to perform ultra-high throughput pathogen and/or viral detection. So let's talk a little bit more about the options that are available to you for microfluidics-based real-time PCR. As we mentioned, the Biomark HD platform is the platform that performs the microfluidic-based real-time PCR, and we've got a whole range of different types of integrated fluidic circuits that can be used for that. The table on the right-hand side of the slide shows the different integrated fluidic circuits and how many samples can be processed and how many assays can be processed per IFC. You can see, for example, the 192.24 IFC can run 192 samples per run across 24 assays, and those 24 assays are assayed in parallel. The 9696 IFC can process 96 samples per run across 96 assays. The 48.48 IFC can process 48 samples per run across 48 assays. This means that our microfluidic-based PCR application can process high volume screening of up to thousands of samples per day. The most popular IFC for pathogen and viral detection is the 192.24 IFC because it's the IFC that runs in the fastest mode, and it's the IFC that can scale in the best way to get you to more than 6,000 samples per day from extracted RNA. The Biomark HD system also offers real-time digital PCR applications. And it means that as part of the COVID-19 and pathogen detection, you can leverage our 12.765 digital PCR or our 48.770 digital PCR IFC to run either 12 or 48 samples respectively on those IFCs. You may recall from the overall introduction session last week that the digital IFCs split your samples up into individual reaction chambers. And so the 12 samples are split into 765 individual reaction chambers, or 48 samples are split into 770 individual reaction chambers. This means that you can be able to get the sensitivity that is required to screen for the viral transcripts using digital PCR. So in summary, before we move on to the actual protocol that we have, Fluidigm and virology screening really do go hand in hand with our microfluidics, with our Juno, and with our Biomark HD system. We offer unparalleled throughput when detecting viral nucleic acids to assess gene expression levels and discriminate pathogens. The take-homes as part of this introduction are that we offer unparalleled scale. We can process up to 6,000 samples per day per instrument. It's expandable. We can process up to 24 targets per sample. That's important because you don't need to just look at COVID. You can also look at other respiratory markers to give you greater comprehension in the assays that you're studying. It's also a flexible approach. We're seeing more and more that people want to use TACMAN, but people also want to use other assay types. Our platform can be used with any type of chemistry. So it supports multiple chemistries that are proven. And as we mentioned last week, and as we mentioned earlier in today's presentation, we are providing superior cost savings, maximizing the budget by minimizing the consumption of reagents and the workflow, saving you time and saving you money per sample type. Let's now go into a little bit more detail on what the protocol is that is dedicated to viral RNA detection. So Fluidigm, as in response to COVID-19, have a protocol dedicated to viral RNA detection. And this is a highly sensitive workflow that starts with viral RNA, for example, from SARS-CoV-2, and providing unparalleled sample throughput and capacity to implement up to 24 assays in the same experiment. Let's take a look at some of the features and benefits associated to our protocol. As shown in the table in the center of the slide, we can detect down to 1 copy per microliter detection. That is our limit of detection. That means per reaction, we can detect down to 5 copies per reaction. We also offer 5 logs of dynamic range. That means that we're able to detect along a large spectra of molecule concentrations. And that's important because, as you know, when you receive samples in your lab, the viral load of each of the samples may be different. Our technology enables you to process up to 6,000 samples per day. That's a throughput level with one system that is unprecedented in other technologies, such as 96-well plates or 384-well plates. Our protocol utilizes the Center for Disease Control IDT validated assays. In other words, you can get those assays from IDT as part of their CDC emergency use authorization protocol and port them over to the Fluidigm microfluidic technology using our protocol. We also offer the ability to look at up to 24 molecular targets in a single run. That is important because it means that your precious sample is interrogating more assays than is possible on a 96 or 384-well plate. Because as we discussed last session, each sample is assayed by all 24 assays at the same time. The microfluidic technology is proprietary to Fluidigm. Our nanoliter reaction volumes, which really is between 6 and 9 nanoliter per reaction, saves the precious samples and ensures low cost per sample. And we're compatible with both fast and standard protocols on our Biomark HD. Fast, meaning that we perform the PCR reaction in just 30 minutes. Standard, meaning that we take the PCR reaction to almost an hour. Of course, most of our users want to run in fast mode so that they can get the scale of 6,000 samples per day. And we also have the dual target plus internal control detection, meaning that you get your COVID marker, but you also get the RNase P control in the same chamber, meaning that you get accurate detection without exhausting the PCR reagents. In summary, our protocol takes what you can do on a 96-well plate using the same technology, using the same TACMAN-based detection, and scales it, and reduces the consumption of reagents, which saves you cost, and also reduces the hands-on time, which also saves you cost, but also means you can get more tests detected per day. So in terms of our workflow specifications, it looks a little bit like this. The image at the top of the slide shows you the upfront work, followed by the work that takes place on our Juno and on our Biomark HD platform. In walking you through this workflow, we start with an RNA sample. That's what's shown in the tube, colored in blue. We then perform a reverse transcription reaction of that RNA to generate the cDNA. Once that cDNA is created, we then perform a specific target amplification or pre-amplification on a standard 96 or 384-well plate. Once that pre-amplification is complete, we then take the pre-amplified cDNA, pipette it onto our 19224 IFC, and place that along with the assays into the Juno system. The Juno system will take around 30 minutes to perform the priming and the sample loading within that IFC. After that 30-minute period, the IFC is then ready to be transferred for what we call high throughput qPCR. In other words, it goes into the Biomark HD platform where the 30-minute fast PCR reaction takes place. That then generates the results in terms of amplification plots of both the target assays as well as the control assays, so that you can see the crossing threshold values and port that into your LIMS system to be able to generate the result. The table below the workflow shows the key specifications. We won't go into detail of all of these, but we will take a couple of snapshots of the important ones. Examples include the runtime for the 192 samples. In standard mode, our runtime is 4 hours 20 minutes, and in fast mode, it's 3 hours 20 minutes. We'll also take a look at the number of samples per run. It's 192. And each sample for the standard COVID markers would be assayed for N1, N2, and RNase-P. N1 and N2 being the COVID markers, and RNase-P being the control marker. And as we mentioned earlier in the presentation, there's room to add your own assays to this. And in the 19224 IFC, with the 3 COVID-specific assays, you can also look at another 21 assays. Let's now look at more detail in terms of the workflow and in terms of the timing. And this is to give you a glimpse into our protocol. So as I mentioned on the previous slide, we start with extracted sample. We then perform reverse transcription on that extracted sample using the Fluidigm reverse transcription master mix. That uses 5 microliters of your sample plus 1.25 microliters of the Fluidigm reverse transcription mix. And that takes 40 minutes to complete. Once that's complete on a standard thermocycler, we then have our pre-amplification step. Pre-amplification is when you take the specific COVID markers along with the RNase-P plus your other 21 markers that you're interested in and perform a limiting PCR reaction. This uses 6.25 microliters of the RT plus 6.25 microliters of the Fluidigm preamp master mix. And that takes 100 minutes to complete, again, on a standard thermocycler. Once that's complete, you perform a dilution, meaning that you can always go back to that pre-amplified material, it's never gone, and then you load that on our 19224 IFC using the Juno. And as mentioned, that takes 30 minutes of hands-off time to process. Once that's complete, you simply remove the 19224 IFC from the Juno and place it onto the Biomark HD platform to perform the real-time PCR amplification. That takes 90 minutes in standard mode, or as most of our customers use, 30 minutes in fast mode. And then we perform the analysis. Most of the components are from Fluidigm. The reverse transcription master mix, the pre-amplification master mix, the 19224 IFCs all come from Fluidigm. You, however, need to get your assays from IDT. And so our protocol for viral detection on the Biomark HD and on the Juno comes from IDT. And if you look in more detail on this protocol, you can see that there's a range of different assays, which you saw on the previous slide, were N1 and N2 and RP. RP stands for RNase-P and is the control assay. In addition, there's a lot of controls that you can get from IDT and Twist Biosciences, and these are listed here at the bottom of the slide. The IDT controls give you positive controls for SARS-CoV-2 and CoV-1. There's also a MERS positive control, and there's also a plasmid positive control for RNase-P. Twist Biosciences also have synthetic controls as well. These are particularly useful when you're trying to validate the assay in your lab. And it's the type of work that's been taking place in sites like Oklahoma and OU Medicine. The Fluidigm workflow, as shown on the next slide, is pretty straightforward. Reverse transcription and specific target amplification are performed in 96 or 384 well plates. That pre-amplified product is always salvageable from the -20. The products that you take which is very small volume used, then go into the 19224 IFC for real-time PCR. The screen grab at the bottom of this slide is a copy of our quick reference card, which is downloadable from the Fluidigm website. This is our actual protocol that we've been talking about so far in this presentation. Before we go into some of the technical details, let's just talk a little bit more about the throughput. One Biomark HD enables you to process a lot of IFCs. So the assumption of what we've been saying all along in this presentation of being able to process more than 30 IFCs in the 19224 format is by following a staggered workflow using one Juno and one Biomark HD. What we count upon is that the previous day you've performed the RNA extraction, you've performed the reverse transcription, and you've performed the preamp or the specific target amplification. These require a standard thermocycler. And once that's complete, you then switch over to our standard workflow using the 19224 IFC on the Juno and on the Biomark. And because of which we do this staggered workflow, it means that it allows the constant processing of samples. And so, up to 30 IFCs can be ran on a single Biomark, a single Juno system in one 24-hour period. That means that you're going to generate 5,760 tests in one day with one system. So I'm sure now we start to think about, well, okay, what does this data look like? We've explained the workflow, we've explained the technology, we've explained the throughput, and we've explained the benefits. But what does the data actually look like using our microfluidic approach? And so in the next few slides, what we want to present to you today is just some examples of the data that we've generated using this workflow. Of course, our experimental design is that a serodilution of SARS-CoV-2 synthetic RNA was spiked in a 5 microliter solution containing 5 nanograms of universal human reference RNA. Reverse transcription and pre-amplification reactions were carried out using the Fluidigm reverse transcription master mix, part number shown, and Fluidigm preamp master mix, part number shown respectively. The gene expression 19224 dynamic array, part number shown, were loaded and primed with a Juno system or our RX controller. To help you understand, the Juno system is the system that prepares all of the IFCs. The RX controller is a smaller system at lower cost that prepares just the 19224 IFC. Nucleic acid amplification reactions were performed using the CDC approved assays from IDT that you saw earlier in the presentation, and the Thermo Fisher Scientific TACMan gene expression master mix for standard mode, or the Thermo Fisher Scientific TACMan fast advanced master mix for fast mode. And the samples were amplified and analyzed using the Biomark HD platform. The first part of our workflow was to determine the dynamic range and the limit of detection. Across 4 integrated fluidic circuits, we were able to establish the limit of detection using the SARS-CoV N1-N2 and using both replicates and the RX, the Juno, in standard and in fast PCR mode. This is shown on this slide. When we look at this in more detail, you can see that the performance summary for N1 and N2 is very clear. You can see on the left-hand side with the plot that our linearity is more than 0.996 for N1 with a limit of detection of 1 copy per microliter across 5 logs. That 5 logs means that we've got 100,000 copies to a single copy. The same type of metric is achieved on the right-hand side with N2. N2 linearity is greater than 0.995 with 1 copy per microliter of limit of detection with 5 logs, again from 100,000 copies to a single copy. The take-home message from this slide is that independent amplification reactions were performed to detect N1 and N2 of SARS-CoV-2 and RNase P. And both experiments targeting N1 and N2 exhibited an excellent linearity of more than an R-squared of 0.995 and the capability to detect the presence of RNA templates below 5 copies per reaction when it's present. This is a very good limit of detection. On this slide, when we look at the dynamic range and the target limit of detection using Fluidigm real-time PCR for viral RNA detection protocol, we're able to show great linearity across 5 logs and the capacity or the capability to constantly detect down to 1 copy per microliter with 95% confidence. And this is shown when we look at the assay of N1 in blue and N2 in orange on this plot. Again, more than linearity of greater than 0.995 for each target, limit of detection of 1 copy per microliter across 5 logs. And if we look at that on the raw heat maps that you get from the Fluidigm real-time PCR analysis software, you can see how we got to 5 copies per reaction. So we are able to detect down to 1 copy per microliter with 95% confidence. That means that when we look at the CDC guidelines, an LOD of 5 copies per reaction was achieved across all conditions. To support this new protocol, we have launched, and as part of the kit, a new assay loading reagent, so-called 4X assay loading reagent. This is part of our kit. So if you're an existing customer and you want to use our new protocol, make sure that as part of the ordering, you order the 4X assay loading reagent. The reason that we did this was that it is compatible with any of the assays and primers and probes that are manufactured at lower concentrations, such as the IDT 2019 novel CoV-2 assay. Further to this, we've also increased our bundling capacity and our products as part of this workflow. Earlier in the presentation, you saw me talk about the reverse transcription using the Fluidigm reverse transcription master mix, the preamplification using the Fluidigm preamplification mix, followed by the workflow for the 19224 GEIFC. And you'll see that on this list, all of the part numbers are listed and all of the components are listed that you need. Use this slide to engage with your Fluidigm account manager to help get the configurations that you require. Other components are also shown here, in particular the 4X assay loading reagent and some of the bulk components that may be required as well. Again, please check with your Fluidigm account manager on what you need. Other documents are shown at the bottom of this slide, such as our real-time PCR for viral detection quick reference card, the manual, and the product inserts for the reverse transcription and the preamplification master mix, as well as the 19224 IFC. The key takeaways for our protocol for viral RNA detection is that the Fluidigm real-time PCR viral RNA detection protocol demonstrates the capability of Fluidigm to detect viral RNA with great sensitivity. The proof of concept data that we've presented in today's webinar targeting SARS-CoV-2 viral RNA demonstrates a 5 log dynamic range and a limit of detection of 5 genome copy equivalents per reaction. That means we're down at 1 copy per microliter. The workflow also enables the performance of multiple steps in the protocol in parallel. That means that you can get to a throughput of more than 6,000 samples per day from extracted RNA. And the protocol can be modified to accommodate different primer and probe sets to target different RNA viruses. The last part of today's webinar is really to talk about some of the publications that exist featuring microfluidics for viral detection. This is really to show you that even before we were hit with the COVID situation that we all find ourselves in, that Fluidigm technology really was being used in the microfluidic sense for the detection of viruses. So just some examples of these protocols that are available. The first example is really using real-time PCR for pathogen detection. And you can see that this study was titled Disclosing Respiratory Co-infections, a broad range panel assay for avian respiratory pathogens on a nanofluidic PCR platform. The objective of the study was to demonstrate proof of concept for development of a high throughput screening protocol to detect respiratory co-infection profiles in poultry. The authors of this paper used the Biomark HD, the Fluidigm IFC controller HX, and our 9696 dynamic array. The conclusions put forward by the authors of the paper, published in Avian Pathology, show that the protocol enabled the authors to develop a high throughput multiplex panel for targeting key poultry respiratory pathogens. Other publications using the Fluidigm technology include digital PCR and qPCR applications. Again, another example here shown published in PLOS ONE shows that this was a novel high throughput method for molecular detection of human pathogenic viruses using a nanofluidic real-time PCR system. The objective was to develop a high throughput method for the detection of 19 human pathogenic viruses and controls. In this example, the authors used the Biomark HD, the 48.770 digital array, and the 4848 dynamic array. Conclusion in this paper showed that combined use of real-time PCR as well as digital PCR provide great assays for high throughput sample screening during outbreak investigation and surveillance. These are not the only publications that feature the Fluidigm technology. There's other publications shown on this slide. We don't have a lot of time to go through these today, but I would encourage that you look up these journals and look at how the Fluidigm technology with microfluidics can be used for pathogen detection. You may also want to visit our website for some information on the collaborations that we have going on at the Mount Sinai School of Medicine, but also at the OU Medicine in Oklahoma, to see how the microfluidic detection and technology can be used to help you to scale for pathogen detection in this time of COVID. Before we wrap up in today's session, this really covered off on the detection and characterization of viral pathogens with microfluidics. The next two sessions really focus on sample tracking and quality assessment, as well as automated nanoscale solutions for RNA-seq libraries. Please tune in to these subsequent spring Microfluidics webinar series. The key take-homes from today's session is that pathogen detection using Fluidigm, Juno, and Biomark HD help you to scale sample throughput by offering microfluidic solutions to enhance testing efforts, enabling high throughput screening of more than 6,000 samples per day. And as a take-home, that's the equivalent of 48 96 well plates. We also offer cost efficiency, delivering high quality data and services at a limited budget. Our screening is available at around $7 per sample. And finally, we offer scale and automation. Only the 19224 IFC can be processed in 1 hour with only 30 minutes hands-on time. Again, thank you so much for your time and attention today, and we'll open it up now for Q&A.